Hello, everyone, and welcome to today's webinar, Higher Purity, Higher Yield, How to Optimize Your Purification Workflow from Lab Scale to Scale Up. I am Kaylee Bach of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by Advion Interchem Scientific. To learn more, visit advion-interchem.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Submit. We'll answer as many questions as we have time for at the end of the presentation. You may also submit any technical issues here as well if you have trouble seeing or hearing the presentation. And with that, I'd like to now welcome our speaker, Chase Needham, Application Scientist at Advion Interchem Scientific. For a complete biography on our speaker, please click on the Presenter tab. Chase, thanks for joining us. You may now begin your presentation.
Hello, everyone, and thank you for coming. Let's jump right in. So Advion Interchem Scientific is a scientific company that produces tools to help laboratory chemists, whether it's identification, purification, or reaction monitoring. We can do all of that for you and help you achieve your goals in the laboratory. Today specifically, we'll be focusing on a few tools that we offer in order to help you streamline your processes in the lab. So we have the Plate Express TLC plate reader, which allows for direct mass analysis of TLC spots in less than 30 seconds. We have the Atmospheric Solids Analysis Probe, or ASAP probe, for direct mass spectra in less than 30 seconds, which is really a sample prep free technique for mass analysis. And then we also offer the PureFlash family of flash purification instruments. Specifically today, we will talk about the XS520, which is our workhorse flash instrument. Okay, so what we'll learn today is how to select the ideal purification solution for your specific needs, how to optimize your purification workflow to automate compound identification and fraction confirmation using simple preparatory free tools. We'll also learn how to select a column for your purification and why that matters to your purification. And then we can discover how you can use your cell phone to actually automatically develop a method with our software, and how all these tools will allow you to streamline your synthesis and purification workflows. So I'll tell you a little bit about our mass spectrometer that we offer. It's the Expression Compact Mass Spectrometer, or CMS. So it's available with the ESI and APCI sources both. In a single run, you can run both positive and negative polarities in case you either do not know what polarity your compound ionizes in, or you have a complete unknown. You'll be able to run both polarities at the same time. And it comes in two models. The Expression S is a mass range up to 1200 m/Z, and the Expression L has a mass range of up to 2000 m/Z. Okay, and then we will also look at the PureFlash XS520 Plus. Again, this is our workhorse instrument for flash purification. It has a pump that allows you to run up to 300 milliliters per minute. It fits columns up to 880 grams in the standard format, but it's also available with a larger external column holder to fit larger columns. It's got a max operating pressure of 20 bar, and it will really allow you to purify up to 800 grams per run. So you can do it from medchem scale all the way up to process scale chemistry with this one instrument. Okay, so what we offer is a complete laboratory solution to optimize your workflow, whether you're talking about the reaction portion and monitoring the reaction, the purification process, or the post-purification compound identification. We can offer tools to help all of that. Okay, so reaction monitoring for most organic chemists starts with a TLC. TLC is a very common, so this is thin layer chromatography, where your spots separate out on a plate, and that allows you to essentially say whether you've made a new compound or your starting material is still present in the reaction mixture. So TLC mass analysis in the traditional way to do it is actually pretty challenging, because what you have to do is you have to develop a TLC plate, you have to scrape out each individual spot, dissolve the compound from the silica, filter off the silica, and then generally you run a LCMS process to identify each spot. However, with the Plate Express, what we can do is we can basically remove that long LCMS wait time. And sometimes you have to send those samples off to a central lab, so it may take hours to get your results, and that can even lead to sample decomposition. So our solution to this is the Plate Express. So this allows for direct TLC MS analysis. So basically you can put a TLC plate into the Plate Express, hit a button, and extract the spots from the plate and get a mass spectrum for that spot in under 30 seconds. Okay, so no further sample preparation is needed other than developing the TLC plate itself. Okay, so how does this work? So you have an isocratic pump pumping solvent into a valve, and then in the Plate Express, you have what's called the elution head that is going to come down and form a nice seal with your TLC plate above your spot. And then the solvent will wash through the elution head, washing your compound out from the plate, filtering out the silica, and then directly into the CMS. Okay, so no more scraping of TLC plates is necessary. You're able to get a mass spectrum from your spot in less than a minute. You're able to avoid overloading the mass spectrometer, which is a common problem with mass spec. And this is really an ideal solution for multi-user labs. Okay, so let's look at a specific example. So a Suzuki reaction, many of you have probably done this if you're organic chemists. So we have a bromine species A and a boronic acid B. Those are our starting materials. There's a base, sodium hydroxide, and a catalyst, palladium chloride. Okay, so those were all placed together in a round bottom flask in 4:1 ethanol water at room temperature and stirred, and then we are looking for the presence of our product E, this 4-amino biphenyl species. Okay, so along the process of the reaction, we took different time points. So at 0 minutes, this would be when everything is mixed together and began stirring, all the way up to 180 minutes, and then developed the TLC plate, have separation. It was spotted against a standard you can see on the right-hand side of the plate. So the product standard is at 0.1 RF, and the 4-bromoaniline starting material is at 0.15 RF. Okay, and what you see is this is developed under a 254 wavelength UV light. Okay, so each spot was then extracted into the Plate Express, and you can see our product spectrum here for the 4-amino biphenyl. So a molecular weight of 169 gram per mole, and then it shows up as a proton adduct, so M plus H at 170. And what you can see at the bottom, in the bottom figure, is that over time, as expected in the reaction, the product is appearing, and what we should also see is the, not shown here, is the reactant disappearing. Okay, so now that we've made our product, we were able to monitor it with the Plate Express. Now we need to work up the reaction and then purify. Okay, and this is where our friend the XS520 comes in. So this is an automated flash purification instrument. So if you're familiar with flash, you've probably done a glass column before. This is kind of the traditional way flash chromatography has been done. Glass columns can be extremely time-consuming to pack and unpack. You have no real-time detection of compounds, so you don't know where your compound is in terms of your fractions. It's difficult to choose the correct column dimensions and how much silica you need. You create many fractions to analyze and work up after the purification. And overall, it's a very manual process. So it can be very difficult to scale these up sometimes. If you start at a medicinal chem scale, let's say maybe a 50 milligram reaction, the purification may not be difficult. But when you scale up to a larger process, you often have difficulty in this manual purification scale up. So automated flash chromatography is actually a big advancement for organic chemists because it saves a lot of time and money. So first of all, there are no columns to pack. Generally, people use pre-packed columns. So they come in different sizes from 4 gram all the way up to multi-kilogram cartridges. You have online detection by either UV, ELSD, or mass spec, depending on the instrument and the detector you have. So what that leads to is that there are fewer fractions to analyze and work up because only the fractions, or excuse me, peaks of interest are collected, and there are fewer fractions without any compound in them. So the other advantage to this is that the user does not need to monitor the purification process. It's something that you can press play on and walk away and do other laboratory tasks. It has the added advantage of using less solvent than the glass columns. Scale up is generally much, much easier in automated flash. And again, overall, it saves time and money, which is very important to the average organic chemist. Okay, so again, our friend, the XS520 flash purification system is going to allow you to do multiple different scales of purifications. It has state-of-the-art technology in a very small footprint. So this can fit in the hood, on the benchtop, wherever you need it to fit in your laboratory, we can make space for it. Okay. We have the TLC to Flash app. So by using your cell phone, you can photograph a developed TLC plate and then begin to develop a method. So by transferring that TLC plate to the IntersoftX Genius software, we're able to automatically generate a gradient and have it suggest column size, as well as whether you should dry load or liquid load. And we'll talk about that a little bit more in upcoming slides. So this is all available from a touch screen. So it's very easy to control and very easy to monitor your purification process. Okay, so our IntersoftX software is a highly customizable interface. So you can kind of make it your own so that you're comfortable with the interface itself. It's very easy to develop methods with or without the Genius app. And then it also allows for you to modify those methods on the fly. So if you want to change to a different wavelength that you're monitoring or change the flow rate, we're able to do that in the middle of a run without issue. Okay, so the TLC to Flash app is going to allow you to simply photograph a developed TLC plate. You can add information if desired. Okay, you'll indicate the origin and solvent front and identify where your product of interest is relative to the starting material using your fingertip. You're going to tell the system how much crude material you have to purify, identify the developing solvents for the TLC. So for the experiment we'll show is cyclohexane and ethyl acetate, 9 to 91. And then you can send that developed application to the PureFlash, and it will develop a gradient for you. Okay, so it automatically calculates your RF values. You don't need to do that. It will also calculate the delta CV, which is your difference in column volumes. It's a measure of separation. It will automatically suggest column size and media type based on separation and crude amount. So it will tell you whether you need a small particle size if you have a difficult purification, or maybe you have a simple purification and you can use large particle size. It will also give you the column size itself. So do you need a 40-gram cartridge, or maybe you need a 120-gram cartridge, depending on the crude amount and the actual separation. The system will also prompt you if you want to make a dry load or liquid load. So basically it'll ask you if your compound is soluble in the starting conditions, and if not, it will suggest a dry load. The system is able to develop a gradient to separate the spots of interest. So in total, you can use up to 14 spots and 10 spots of interest. Of course, there are some parameters to allow it to separate them all, but you can use a pretty complex TLC plate to make a purification with some confidence, okay? And then following the run, you can review your chromatogram using the touchscreen and identify where your fractions are that contain your peaks of interest. And this is just a view of what your Genius software looks like. So you can see we have 3 spots here. We put in the crude amount, the solvents, and then it's suggesting different columns. Okay, so what this allows for is easier and faster purification of your compounds. So you no longer need to be an expert in chromatography to set up a gradient. You can set up a gradient using your TLC plate that gives you high confidence level of being able to separate those compounds. It will detect the RF values automatically, and then you also recommend a column. So all of this is going to cut down on the development time for your method. And the touchscreen will make programming and viewing data faster and easier. So you can see we go from our input information to a method that is allowing us to separate all 3 of those spots. Scale up is also very easy with the InterSoftX software, okay? So if you develop a method on, let's say, a 4-gram cartridge, to scale it up to a 40-gram cartridge is not challenging. You're just simply going to tell the system you're using a larger cartridge and have it change the flow rate and times for your gradient. And it's really as simple as that. And again, you can accommodate up to 880-gram cartridges in the standard format. So it's a fairly large purification scale. So at AIS, we offer a wide range of flash columns. So the star of the show for me is the 15-micron spherical silica. This allows for improved peak shape and resolution, which in the end equals more purification power, shorter run times, more money saved on solvent. So that's a virgin silica, but we also offer several different C18 bonded phases, which are good for a wide range of polar and nonpolar compounds. We offer an amino bonded silica, which is an alternative to virgin silicas for basic compounds. We offer the diol phase, which is great for high polarity compounds with poor retention on C18. We offer 4 available chiral phases packed into flash columns. And then we also have many other types of medias, which I won't cover here. So we have a media for every application and every scale, and we have cartridges, depending on the media, from 4-gram all the way up to 10 kilogram. So from medicinal chem scale to process scale. Okay, so now that our purification is done, we need to identify where our compound is and work up the fractions that contain it. Okay, and here you can see the XS520 next to our CMS and Plate Express, all taking up relatively small amount of bench space. Okay, so fraction ID generally is done via more TLC, maybe sometimes LCMS. So you'll need to spot several fractions, develop TLC plates. It can be a time-consuming process. But one of the tools that we offer is actually what's called the ASAP source. Again, this is the Atmospheric Solids Analysis Probe. So it's a dipping probe that can be used with the expression CMS that allows quick capture of mass spectra with little to no sample preparation. It avoids direct injection, which often leads to overloading of the mass spec. It can avoid lengthy LCMS runs. And you can really see your data very quickly in less than 30 seconds by simply dipping the probe into a fraction and then inserting it into the mass spec. So you have full confidence that your compound is there as long as you're able to ionize it. Okay, and just to give you some more information on the ASAP probe. So it is a streamlined sampling experience. So it's the same ionization process as APCI, but instead of doing a liquid injection of some kind, you're simply coating the glass capillary at the end of the probe with your sample and then sticking it directly into the source. Hot nitrogen gas stream will come off and disassociate the compounds from the glass capillary, and then the corona discharge pen will allow the APCI ionization mechanism, and then straight into the mass spec. So what are the benefits of this? You have no sample preparation. You simply swipe the probe across a liquid or solid sample and then insert directly into the mass spec. There's absolutely no chromatography needed, and you can get publication quality data in less than 1 minute. So this is a very affordable way to do sample analysis because, again, no solvent means saving money. Okay. So just to reiterate the workflow, so you'll identify the fractions from the XS520 using the UV profile or whichever detector you're using to detect your compounds. Make sure that you've separated your compounds as expected. You'll take this central fraction from each peak, dip the ASAP probe into that fraction, and then insert it into the mass spec and confirm that your compound is present in seconds. So you can see here, this bromo species, we actually have 2 peaks in the mass spec, but that's because of isotopic ratios. So the bromine gives you 2 peaks. And that is exactly as we expect. And then in the product, we do not see the doubling of the brominated peak. We see the mass that we expect at 170, which is our product. Okay. And then after you have finished your purification, you have a couple options from AIS to concentrate your solutions. So we now offer the RVAP, which is a rotary evaporator. It can accommodate flask sizes of up to 3 liters and has a temperature bath from ambient temperature all the way up to 230 degrees C. Okay, and then our XS-VAP is a nitrogen evaporator. It's able to evaporate up to 90 samples in parallel and is compatible with our PureFlash racks. So that means you can take your rack directly from the purification instrument and place it into the XS-VAP and then concentrate your sample in an inert atmosphere. And it's compatible with a very wide range of solvents. Okay, and then we also offer the Avant, which seamlessly integrates into the CMS. This is our HPLC. So you can run LCMS for confirmation and purity analysis of your compounds. And again, it's available in the HPLC or UHPLC configurations, depending on your needs. So to reiterate our complete workflow, we're able to help you in the reaction monitoring process via the Plate Express. So develop your react your reaction, spot, and develop your TLC plate, and then analyze your spots via the Plate Express. Then purify using the XS520 and our Genius application, which can develop your gradient and method for you. And then sit back and relax, let your purification run, have a cup of coffee. And then once your run is complete, you can locate your fractions using the UV profile, and the ASAP probe will give you complete confidence that you know your compound is in those fractions. Okay, and that's all I have for you guys today.
Great. Well, thank you so much, Chase, for your informative presentation. We will now start the live Q&A portion of the webinar. So to our audience, if you have a question that you'd like to ask, please do so now. Just click on that Ask a Question box located on the far left of your screen, and we'll answer as many of your questions as we have time for. All right, so we've already got some great questions coming in here. This first question that I have for you, Chase, this question asks, can I use the XS520 for both normal and reverse phase purifications?
Absolutely, yes. We actually have on the XS520 a quaternary gradient valve, meaning you can have up to 4 solvents on the system at any given time. Generally, you're not going to need 4 solvents in your purification, but you could dedicate your first 2 channels to maybe normal phase solvents like ethyl acetate and hexane, and then your back 2 solvents as a reverse phase application, like with water and methanol. So absolutely, and it's very easy to switch in between the 2 modes just by simply flushing the system with a solvent that is friendly, generally isopropanol, and then you can switch between reverse phase and normal phase in maybe as little as 2 minutes.
Great, thank you. I have another question for you here. This one asks, how do I choose my column size for a purification?
Oh, good question. So column size is always going to be determined by a couple of factors. So the number one factor is going to be the amount of crude material you have. Obviously, more crude material means you need more silica to purify it. So that's the number one factor, but then you're also tightly constrained by how good your separation is on the TLC plate. So if you have a very poor separation, you're generally going to need a larger column, and it really will depend on how many spots you are actually interested in purifying, how far those spots are away on the TLC plate, and then again, how much sample you have in order to purify.
Great, thank you, Chase. This next question asks, what is the advantage of smaller particle size silica?
Okay, so I mentioned that we have 15 micron silica. So the standard silica for most purifications is a 50 micron particle size. So the smaller the particle size, the higher the efficiency of the purification media is. What that means is basically it allows you to separate your compounds in space more efficiently. So if you have a very close separation on TLC plate, you're almost always going to want to go to the smallest particle size you can. That way you can ensure that you have the best separation on column possible. So 15 micron is the smallest offered in the industry. There is also a consideration of particle shape. So most commonly people use irregular silicas. Irregular silicas have an irregular shape, as it sounds. The spherical silicas have a more uniform spherical shape that allows the packing efficiency to also increase because you basically have a more uniform pack because all of the particles are relatively the same shape and size.
Great. All right, it looks like we have time for one more question here, so we'll wrap up after this one. This question asks, can I use the Plate Express with C18 TLC plate?
Yes, so you can use the Plate Express with just about any media that's available on a TLC plate. C18 is very common. You can also use it with alumina or an amino bonded phase, really any TLC plate you have. There's only a few considerations you need for the TLC plate. Number one is that the thickness needs to be between 200 and 250 micron of silica. And this is something you can ask your manufacturer of your TLC plate, that they always have those specifications. The only reason that is a requirement is that that's the optimum thickness for the plate for it to have a good seal, so that you don't have any leaking from the elution head. But yeah, C18 is commonly used by our users, and there are no issues with using different types of media other than a normal virgin silica TLC plate.
Great. Well, thank you so much, Chase. That will conclude our session for today. Do you have any final comments for our audience?
I'd just like to thank everybody for coming and joining us today. And if you have any questions in the future, please don't hesitate to reach out to AIS. We're here to help scientists achieve their goals.
Great. Well, thank you again, Chase, for your time today and your important research. We would also like to thank LabRoots and our sponsor, Advion Interchem Scientific, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today and those submitted during the on-demand period will be addressed by our speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand, and LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. So until next time, take care, everyone. Goodbye.